Hello class, we will be starting chapter 1.4 over angle measure. So again, just like we've done every notes, make sure that you put the date at the top right hand of your notes. Now the first definition we're going to look into is degree, which can be simply defined as a way of measuring angles. Again, that's way of measuring angles. Now the second thing that we're going to come across, we have the definition for a part of a line with one endpoint and extends indefinitely in one direction. Now this definition represents a ray. So in our diagram, we are going to draw what a ray looks like. So like it says, a ray is a part of a line with one endpoint and extends indefinitely in one direction. Now, to draw a diagram of a ray, we need to create one point, which we'll say is A, and then create another point at B. Now we're going to create it just like we did a line, except we are only going to extend the ray from one endpoint through the other point. So one part's going to have an endpoint and the other part will have the arrow that extends indefinitely in one direction. Now the way that we name a ray is actually kind of important. So before, when we did a line, the order didn't matter. We could call it either line AB or line BA. Now when it comes to drawing rays, there is a matter of importance when it comes to order. So we always will start with the endpoint, which in this case is A, and then we will do its second point B. The symbol that we'll put above AB is going to look just like a ray. It's going to be an arrow that points to the right. Another way you can also call this is ray AB. The second definition we come across is opposite rays, which can be defined as two rays, BA and BC, such that B is between A and C. Again, that's two rays, BA and BC, such that B is between A and C. An example drawing of opposite rays, we can say we draw a line where we have points A, B, and C. So we have ray BC, and we also have ray BA. These are both opposite rays. Now, a set of opposite rays are actually collinear, which, remember, the definition of collinear is that they are all points on the same line. Now we'll get into the definition of an angle, which an angle can be defined as the intersection of two non-collinear rays at a common endpoint. Again, that is the intersection of two non-collinear rays at a common endpoint. Now when we look at our diagram, the two rays that we have are ray AB, and we also have ray AC. They both have a common endpoint at A. So this actually creates our angle. Now the way that we would name this angle, there are two different ways that we can name it. We can use 2 points on the ray with the common endpoint being the middle, or we can also use the number that is inside the angle. So the first way that we could do it is we're going to use the angle symbol, and we can write it as angle BAC. So B is one point on the ray that is not the common endpoint. A is the common endpoint, or where the angle is formed, and then C is on the other ray. Now we could also call it by the number it gives us. In this case it gives us 4. So we could also call this angle 4. Now another way that you guys can write the angle symbol if you want, I don't personally do this, but some people will. You can use the angle symbol with a little line that goes towards the angle. So that's another way that you guys can write it as well. That will be up to you. Now in example 1, it tells us to name all angles that have B as a vertex. So this means B is our common endpoint between our two rays. So now we're just creating every angle that has B as your common endpoint, or what we call the vertex. Now, when we look at this problem, we can see a couple different things on here. So with B as a common endpoint, we could say that we have ray AB and ray BD. So that can help us create one angle, which we can call angle ABD. So that's one angle we have. Now another angle we can do with AB, or with B as your vertex, we can also do ray BA and also ray BC. Now remember, there's two ways we can write it. We can write it as angle ABC, or since this one actually has a number with it, we can write it as angle 1. Now, there's another way that we can write this, is if we look at B again as a vertex. We have BA, and we also have BE. So this creates an angle between A, B, and E. So we can write that as angle ABE, or for short, which makes it a little easier, we can write it as angle 3. Now there's one final way that we can write this. We can think of it the same way we found angle 3. Now what we can do is we can use ray BE and also ray BD. Now this one does not have a number for the angle, so we're going to have to write it as an angle with 3 letters to it. So remember, B is our vertex, so that's going to be the middle part of our angle. So we can call this angle EBD. Now there's one final way to create an angle using B as your vertex. Now what we can do is we can use ray BC and also ray BD. So the final way that we can create an angle here is angle CBD. Now in part 2, it tells us to name the sides of angle 2. So when we look at angle 2, angle 2 is formed by ray BC and also ray BD. Now, to name the sides, those are going to be your segments that are created there, or that create your angle C. So in this case, when we look at angle 2, we have BC that is one side, and we also have CD. So our answer would be written as segment BC and also segment CD. Now, CBD actually creates a triangle, so that's why it's asking you for the sides, because each triangle has 3 angles. Now, moving on to example 1C. It tells us to write another name for angle BCD. So it gives us that the angle we're looking at is BCD. So BC is going to be your first ray. When you look at angle BCD, it tells you that C is your common vertex, or your common endpoint, excuse me. So this is your vertex, that middle part. And then it tells us CD as well. Now remember, if it gives us a number, we can also call it by that number instead of using 3 points. So in this case, it tells us that we can use 2 to make this angle. So we can write this answer as angle 2. Now finally, in part D, it tells us to name a point on the exterior of CBD. So we look at our angle CBD. Remember, B is our common endpoint or vertex, and it tells us we have ray CB and also ray BD. So it's telling us that to find a point on the exterior. So exterior means on the outside. So this is the angle we're looking at, is CBD. So we can actually shade that in. We need to find a point that is not within that shaded area. Now, we see that there are no points on the inside. However, on the outside or the exterior, we have the point A. The point A is not included in our shaded area, so that will be the point that is our exterior. So we call it point A. Now please continue on to part 2 of our 1.4 notes over angles.